In this lecture, we will find the area of the green triangle. In the drawing, we have triangle ABC, that is an equilateral triangle. That is to say, all its sides are equal to each other. AB equals to BC equals to AC, and the angles all of equilateral triangle all are equal to 60 degrees. So actually angle BAC equals to 60 degrees. Angle ABC, this angle equals to 60 degrees. And angle BCA equals to 60 degrees. And as I've already said, AB equals to BC equals to AC, and also we know that AF equals to BF, and BD equals to 2 units, and DC equals to 4 units. So actually BC, side BC of the equilateral triangle equals to BD plus DC. Again, BC equals to BD plus DC. Therefore, BC equals to BD, that is 2 units, plus DC, that is 4 units. That is to say, BC equals to 2 plus 4 units, BC equals to 6 units. Therefore, actually all the sides of this equilateral triangle ABC equal to 6 units. Okay, AB equals to BC equals to AC equals to 6 units. Okay, but AB equals to 6 units from one side, but here we know that AF equals to BF. So if we define AF as X, that is to say, if AF equals to X, then BF that equals also to AF will also be equal to X. Okay, so what is the size of AB? AB equals to AF plus BF, or AB equals to AF, that is X, plus BF, that is also X. In other words, AB equals to 2X. So actually, well, from one side AB equals to 6 units, and from the other side AB equals to 2X. So we can derive this equality, that 2X equals to 6. Okay, 2X equals to 6. And if we divide this equality by 2, we will get that X equals to 3 units. Okay, X equals to 3 units. Therefore, AF that equals to X equals to 3 units, and BF that also equals to X equals to 3 units. Okay, in the next step we will define FD as A, that is to say FD equals to A, and we will define DE as B, that is to say DE equals to B. And we will find the size of FD that equals to A by the law of cosines. Okay? What is the law of cosines? First of all, the law of cosines apply to any triangle. So we can write here that in any triangle, it is true for any triangle. We can use it for any triangle. So if we have a triangle if the length of this side in the blue triangle, this blue triangle is A, and the length of this side of the blue triangle is B, and the angle between side A and side B of the blue triangle is theta, and the length of this side of the blue triangle is C, then according to the law of cosines, the following relationship exists between the sides of this blue triangle to the angle theta. According to the law of cosines, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Again, in any triangle, C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay, so we actually can implement the law of cosines in the small triangle FBD. So in the small triangle FBD, according to the law of cosines, FD squared equals to BF squared plus BD squared minus 2 times BF times BD times cosinus 60 degrees. Again, according to the law of cosines, in triangle FBD, FD squared that is fd square equals to bf square equals to bf square plus bd square minus 2 times bf times bd times cosinus 60 degrees. Fd square equals to bf square plus bd square minus 2 times bf times bd times cosinus 60 degrees. Okay, but we know that the value of fd is a according to our definition, so fd square is actually a square equals to bf square. Bf equals to 3 units, so bf square is 3 square. 3 square is 9 plus bd square. bd equals to 2 units, so bd square is 2 square. 2 square is 4 minus 2 times bf is 3 times bd is 2 times cosinus 60 degrees. Cosinus 60 degrees is 1 over 2. So in total we got that a square equals to 9 plus 4 minus 2 times 3 times 2 over 2. 2 over 2 is 1, so 2 is cancelled. And what is left here is a square equals to 9 plus 4 is 13, and 2 times 3 is 6. So a square equals to 13 minus 6. That is what is left after we cancel 2. Okay, so I write it down. A square equals to 13 minus 6. Okay, a square equals to 13 minus 6. 13 minus 6 is 7. So we got that a square equals to 7. A square equals to 7. Here we will take out a root. We will take a root out of this equality, and we will get that a equals to root 7 units. Okay, a equals to root 7 units. Okay, so we found out that the value of a, that is fd, equals to root 7 units. Okay, in the next step we will define angle BFD as theta, angle FDB will be defined as alpha, angle EDC will be defined as gamma, and angle DEC will be defined as beta, and we will find out the value of sinus theta, of this angle sinus theta, according to the law of sines. What is the law of sines? First of all, the law of sines apply for any triangle. So I write here that in any triangle, you can use it in any triangle. I write here that in any triangle, so actually if we have triangle if the length of this side of the blue triangle is A, the length of this side of the blue triangle is B, and the length of this side of the blue triangle is C. This angle is alpha, this angle is beta, and this angle is gamma. Then, according to the law of sines, the following relationship exists between the sides of the blue triangle to the angles of the blue triangle. A over sinus beta, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, again, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. It is true for any triangle. So we actually can implement the law of sines in the small triangle FBD. So in the small triangle FBD, according to the law of sines, FD over sinus 60 degrees equals to BD over sinus theta. So the implementation of the law of sines in the small triangle FBD is FD over sinus 60 degrees, FD over sinus 60 degrees equals to BD over sinus theta. Okay? But what is the value of FD? FD that equals to A, we have already found out the value of A. A equals to root 7 units. Okay? Root 7 units. And sinus 60 degrees equals to root 3 over 2. BD equals to 2 units, and sinus theta, it is actually the missing variable that we want to find the value of it, and we will find the value of sinus theta according to our this equality. Okay, because the only missing variable in this equality is sinus theta. Here we will move 2 to the numerator and root 3 to the denominator. Okay, we will get that 2 times root 7 over root 3 equals to 2 over sinus theta. Okay, 2 times root 7 over root 3 equals to 2 over sinus theta. Here we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of the other side of the equation, so we can cancel 2. And what left after we cancel 2? What is left is actually root 7 over root 3 equals to 1 over sinus theta. Okay, so that is what's left after we cancel 2. In this equality, we will multiply this equality by sinus theta. We will get that root 7 over root 3 times sinus theta equals to 1. Okay, root 7 over root 3 times sinus theta equals to 1. We will multiply this equality by root 3. We'll get that root 7 times sinus theta equals to root 3. Okay, we multiply this equality by root 3. We got that root 7 times sinus theta equals to root 3. In the next step, we will divide this equality by root 7 in order to get the value of sinus theta. We will get that sinus theta equals to root 3 over root 7. So we found out the value of sinus theta. Sinus theta equals to root 3 over root 7. In the next step, we will find the value of cosinus theta by using a trigonometric identity. The first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. We will use this trigonometric identity in order to find out the value of cosinus theta. Here we will subtract from this trigonometric identity sinus theta squared. We will get that cosinus theta squared equals to 1 minus sinus theta squared. Okay, we subtracted sinus theta squared from this identity. We got that cosinus theta squared equals to 1 minus sinus theta squared. Here we will take a root out of this equality, and we will get that the value of cosinus theta is equals to the root of 1 minus sinus theta squared. Okay, so we found out the value of cosinus theta. Cosinus theta equals to the root of 1 minus sinus theta squared. But we have already found out the value of sinus theta. We know that sinus theta equals to the root of 3 over root 7. So we can write here that sinus theta equals to the root of 3 over root 7. Okay, so we got this equality that sinus theta equals to root 3 over root 7. In the next step, we will square this equality, and we will get that the sinus theta squared equals to root 3 squared is 3 and root 7 squared is 7. So we found out the value of sinus theta squared. In the next step, we will substitute sinus theta squared from this equality by 3 over 7, because sinus theta squared equals to 3 over 7. And we will get that cosinus theta equals to the root of 1 minus, instead of sinus theta squared, we will write 3 over 7. So we got this equality that cosinus theta cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7. So I will write it down. Cosinus theta equals to the root of 4 over 7. So we found out that the value of cosinus theta equals to the root of 4 over 7. Root of 4 is 2, so I will write it down. So we found out that the value of cosinus theta is actually 2 over root 7. Okay, the value of cosinus theta is 2 over root 7, and we have already found out that the value of sinus theta is actually root 3 over root 7. Okay, so we found out the value of cosinus theta and sinus theta. Okay, in the next step, we will create 4 equations from this drawing. The first equation is related to the small triangle FBD. In the small triangle FBD, the sum of the angles in triangle FBD equals to 120 degrees. So that will be our first equation. The statement that the sum of the angles in triangle FBD equals to 180 degrees. That is to say 60 degrees plus alpha plus theta equals to 180 degrees. Okay, so that is our first equation that states that the sum of the angles in triangle FBD equals to 180 degrees. The second equation will relate to triangle EDC. Actually the same statement in triangle EDC. Equation number 2 will be the statement that the sum of the angles in triangle EDC equals to 180 degrees. So actually 60 degrees plus gamma plus beta equals to 180 degrees. Okay, our second equation states that the sum of the angles in triangle EDC equals to 180 degrees. In the next step, we will add equation number 1 to equation number 2, and we will create equation number 3, that is the addition of equation number 1 to equation number 2. Okay? So 60 plus 60 is 60 degrees plus 60 degrees is 120 degrees. And here we have alpha plus theta plus gamma plus beta equals to 180 degrees plus 180 degrees is 360 degrees. Okay, so we created the third equation, that is the addition of equation number 1 to equation number 2. Here in the third equation, we can subtract 120 degrees from both sides of the equation, and we will get that alpha plus theta plus gamma plus beta equals to 240 degrees. Okay, 360 degrees minus 120 degrees is 240 degrees. In the next step, we will create equation number 4. As you already know, if we relate to a specific point at any straight line or line segment, the sum of the angles in the upper side of a specific point of a straight line or line segment equals to 180 degrees. So here, if we relate to point D that is on the line segment BC, if we relate it to point D and to the upper side of line segment BC, we can say that gamma plus 90 degrees plus alpha equals to 180 degrees, because if we relate to a certain point and to the upper side of any straight line or line segment, the sum of the angles are equal to 120 degrees. So the further question will be y plus gamma plus 90 degrees plus alpha equals to 180 degrees. Okay, so that is our fourth equation that states that the sum of the angles at a certain point at the upper side of any straight line or line segment equals to 180 degrees. Okay, so here we can subtract 90 degrees from equation number 4, and we will get that gamma plus alpha equals to 90 degrees. So from equation number 4 we have the following equality, that gamma plus alpha equals to 90 degrees. But actually we have gamma plus alpha in equation number 3 also. We have here alpha plus gamma, and we know that alpha plus gamma equals to 90 degrees, so we can subtract alpha plus gamma by 90 degrees in equation number 3. Okay, so we will do it now. We will subtract alpha plus gamma, we will substitute alpha plus gamma by 90 degrees in equation number 3. Okay, we will get that 90 degrees plus theta plus beta equals to 240 degrees. Okay, after we substitute alpha plus gamma by 90 degrees, we got in equation number 3 that 90 degrees plus theta plus beta equals to 240 degrees. Here we will subtract 90 degrees from equation number 3, and we will get that theta plus beta equals to 150 degrees. Okay, according to equation number 3, theta plus beta equals to 150 degrees. Here we will subtract theta from this equality, equation number 3, and we will get that beta equals to 150 degrees minus theta. Okay, so from equation number 3 we got that beta equals to 150 degrees minus theta. But if beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Very simple. So we have the equality that states that sinus beta equals to sinus of 150 degrees minus theta. Okay, sinus beta equals to sinus 150 degrees minus theta. In order to find out the value of sinus 150 degrees minus theta, we will use the second trigonometric identity that states that the value of sinus alpha minus beta is sinus alpha cosinus beta minus sinus beta times cosinus alpha. Okay, that is our second trigonometric identity that we will use in order to find out the value of sinus 150 degrees minus theta when we substitute alpha by 150 degrees and beta by theta. The second trigonometric identity states that sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, so what is the value of sinus 150 degrees minus theta? It actually equals to sinus 150 degrees times cosinus theta minus sinus theta times cosinus of 150 degrees. Okay, so we used the second trigonometric identity in order to find out the value of sinus 150 degrees minus theta, that is actually equal to sinus beta. Okay, so what is the value of sinus 150 degrees? Is 1 over 2 and we have already found out that the value of cosinus theta is 2 over root 7, so we can write here that cosinus theta equals to 2 over root 7 minus sinus theta. We have already found out that the value of sinus theta is root 3 over root 7. Okay, so we write here root 3 over root 7, that is the value of sinus theta, and the value of cosinus 150 degrees is minus root 3 over 2. So here we have 2 over 2, 2 over 2 is 1, so 2 is cancelled. And we have also minus times minus, minus times minus is plus, and root 3 times root 3 is 3, so I write it down. So here we got that 1 over root 7 plus 1 over root 7 times 3 over 2. So in total we got that cosinus 150 degrees minus theta that is actually equals to sinus beta equals to 1 over root 7 plus 1 over root 7 times 3 over 2. Here we will take out 1 over root 7 as a common factor. Okay, we will take out 1 over root 7 as a common factor of this expression, and inside the brackets we will have 1 plus 3 over 2. Okay, so we got that the value of sinus beta is 1 over root 7 times 1 over 3 over 2. 1 plus 3 over 2, 1 plus 3 over 2 equals to 2.5. So, and 2.5 is 5 over 2, so we got the value of sinus beta. Sinus beta will be equal to 1 over root 7 times 5 over 2, because 5 over 2 is 2.5. So we found out the value of sinus beta. Sinus beta equals to 5 over root 7 times 2. Okay, so after we found out the value of sinus beta, we will use the law of sines in triangle DEC in order to find out the value of B, that is actually DE. Okay, so according to the law of sines, the implementation of the law of sines in the small triangle DEC, this triangle, is DE over sinus 60 degrees equals to DC over sinus beta. Okay, so according to the law of sines in triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. Okay, again, DE over sinus 60 degrees equals to DC over sinus beta. The value of DE is B, according to our definition. DE equals to B, and sinus 60 degrees equals to root 3 over 2. The value of DC is 4 units. And we have already found out that sinus beta equals to 5 over root 7 times 2. Okay, so in total we got this equality. Here we can move 2 to the numerator and root 3 to the denominator, and in the other side of the equality we can move 2 times root 7 to the numerator and 5 to the denominator. Okay, we will get that 2 times b over root 3 equals to 2 times root 7 times 4 over 5. Okay, so here we have 2 in the numerator of this side of the equation and 2 in the numerator of the other side of the equation, so we can cancel 2. And what left after we cancel 2 is b over root 3 equals to root 7 times 4 over 5. Okay, so that is what is left after we cancel 2. B over root 3 equals to root 7 times 4 over 5. Here we will multiply this equality by root 3 in order to get the value of b. Okay, so actually here we will get that the value of b is root 7 times root 3 times 4 over 5 units. Okay, so we found out the value of b equals to root 7 times root 3 times 4 over 5 units. And we have already found out that the value of a is root 7 units. Okay, and the area of the green triangle equals to the base of the triangle, that is b, times the height to the base, that is a. A creates 90 degrees with the base b, so the height is indeed a, so it is b times a over 2. That is the area of the green triangle FDE. Okay, so the area of the green triangle FDE equals to the base of the triangle, that is b, times the height to the base, that is e, over 2. We have already found out the values of a and b, and the only thing that is left is to substitute a by root 7 and to substitute b by the value of b. that we have already found. Okay, so we will do it now, and we will get that the area of the green triangle FDE equals to B is root 7 times A is root 7, A is root 7, B is root 7 times root 3 times 4 over 5, and all divided by 2. Okay, so that is the area of the green triangle FDE. Here root 7 times root 7 is 7, and 4 over 2 is 2, so I will write it down. So the area of the green triangle FDE equals to 7 times root 3, and 4 over 2 is 2 over 5. Okay, the area is 7 times root 3 times 2 over 5. But 7 times 2 is 14, so I will write it down. So the area of the green triangle FDE will be 14 times root 3 over 5 square units. Okay, so the area of the green triangle FDE equals to 14 times root 3 over 5 square units. And if we want to express the area in terms of numbers, then we will get that the area of the green triangle FDE equals to 4.85 square units. Okay, in terms of numbers, the area of the green triangle FDE equals to 4.85 square units. Again, the area of this green triangle FDE equals to 4.85 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this green triangle. This green triangle is also a right triangle because of the fact that angle FDE equals to 90 degrees. It is a right angle. And the green triangle FDE is inside the big triangle ABC, that is an equilateral triangle. Triangle ABC is an equilateral triangle, that is to say all its angles are equal to 60 degrees, and all the sides of triangle ABC or any equilateral triangle are equal to each other. That is to say AB equals to BC equals to AC. Okay, and we also know that AF equals to BF, and we know that BD equals to 2 units and DC equals to 4 units. And we want to find out the area of the green triangle FDE that is also a right triangle. Okay? So First of all, as I've already told you, the sides of any equilateral triangle are equal to each other. That is to say, AB equals to BC equals to AC. But what is the size of side BC of the equilateral triangle ABC? BC equals to BD plus DC. Again, BC equals to BD plus DC. And we know that BD equals to 2 units and DC equals to 4 units. So DC equals to BD, that is 2 units, plus DC, that is 4 units. That is to say, BC equals to 6 units. Okay, so if BC equals to 6 units, then all the sides of the equilateral triangle ABC equals to 6 units. And in relation to side AB of the equilateral triangle ABC, we know from one side that AB equals to 6 units. But from the other side, AB equals to AF plus BF. And AF is X and BF is also X. So AB equals to AF, that is X, plus BF, that is also X. So AF equals to X plus X, that is 2X. AF equals to 2X. AB equals to 2X. AB equals to AF plus BF, that is X plus X, so AB equals to 2X. So from one side we know that AB equals to 6 units, and from the other side we know that AB equals to 2X. So we can derive this equality that 2X equals to 6 units, and we can divide this equality by 2. We divided this equality by 2 and we got that the value of X is 3 units. That is to say, AF that equals to X equals to 3 units, and BF that is also equals to X equals to 3 units. Okay, then we defined DF or FD as A, that is to say FD equals to A according to our definition, and we also defined DE or ED as B, that is to say DE equals to B. And then we found out the value of FD, that is A, according to the law of cosines. What is the law of cosines? The law of cosines can be used in any triangle, so it is in any triangle we can implement the law of cosines. C squared equals to A squared plus B squared minus 2 times A times B times cosinus theta. Okay? And we actually implemented the law of cosines in the small triangle FBD in this triangle. According to the law of cosines in triangle FBD, FD squared equals to BD squared plus BF squared minus 2 times BD times BF times cosinus 60 degrees. Okay, according to the law of cosines in triangle FBD, FD squared equals to BF squared plus BD squared minus 2 times BF times BD times cosinus 60 degrees. We know that FD equals to A according to our definition. BD equals to 2 units and FB equals to 3 units. So we have all the values of all the variables inside this equality. The only missing variable is A, so we put the data inside this equality and we got the value of A. A equals to root of 7 units. Okay, A equals to the root of 7 units, and the next step We defined angle DFB, this angle is theta. We defined angle FDB is beta. We defined angle EDC is alpha, and we defined angle CED is beta. And we implemented the law of sines in triangle FBD in order to find out the value of sinus theta. What is the law of sines? The law of sines applies to any triangle, and in any triangle A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay? So we implemented the law of sines in the small triangle FBD in order to find out the value of sinus theta. According to the law of sines in triangle FBD, FD over sinus 60 degrees equals to BD over sinus theta. Okay, in triangle FBD, FD over sinus 60 degrees equals to BD over sinus theta. But we have already found out that the value of FD is actually equals to A, and it equals to root 7 units. Okay, so FD equals to the root of 7 units. Sinus 60 degrees is root 3 over 2. BD equals to 2 units, and sinus theta is the only missing variable. So we put the data inside this equality, and we found out that the value of sinus theta is root 3 over root 7. Okay, then we found the value of cosinus theta according to the first trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. From this trigonometric identity, we subtracted sinus theta squared. We got that cosinus theta squared equals to 1 minus sinus theta squared. Then we took a root out of this equality, and we got the value of cosinus theta. Cosinus theta equals to the root of 1 minus sinus theta squared. And we already know that the value of sinus theta is root 7, root 3 over root 7. So we squared this equality, and we got that the value of sinus theta squared equals to 3 over 7. Okay, so we can substitute sinus theta squared from this equality by 3 over 7, because sinus theta squared equals to 3 over 7. So we substituted sinus theta squared by 3 over 7, and we got that cosinus theta equals to root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7. So we got that cosinus theta equals to root 4 over 7. Root 4 is 2, so we got that the value of cosinus theta is 2 over root 7. And we have already found out that the value of sinus theta is root 3 over root 7. Okay, so we have the value of cosinus theta and sinus theta. In the next step, we created 4 equations from this drawing. The first equation relates to triangle FBD. In triangle FBD, we can say that the sum of its angles equals to 180 degrees. So the first equation is related to triangle FBD, and the statement of the first equation is that the sum of the angles in triangle FBD equals to 180 degrees. Then, in the same way, we created equation number 2, in relation to triangle EDC, the statement of equation number 2 is that the sum of the angles in triangle EDC equals to 180 degrees. Okay, that is our second equation that states that the sum of the angles in triangle EDC equals to 180 degrees. Then we added equation number 1 to equation number 2 and created equation number 3, that is the addition of equation number 1 to equation number 2. Okay, then we also created equation number 4 in relation to point D. We can say that in any line segment or in any straight line, the sum of the angles in the upper side of any line segment or in any straight line equals to 180 degrees. So in relation to point D and line segment BC, the sum of the angles in the upper side of line segment BC equals to 180 degrees. That is to say, gamma plus 90 degrees plus alpha equals to 180 degrees. Okay, that is our fourth equation. Gamma plus 90 degrees plus alpha equals to 180 degrees. And by solving equation number 3 and 4, we got to the equality that states that beta equals to 150 degrees minus theta. Okay, so if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta. Okay, in order to find out the value of sinus 150 degrees minus theta, use the second trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, and we substituted alpha by 150 degrees and beta by theta, and we found out the value of sinus 150 degrees minus theta, that is actually equals to sinus beta. So we actually found out the value of sinus beta, that sinus beta equals to 5 over root 7 times 2. Okay, so we found out the value of sinus beta, and then we implemented the law of sines in triangle EDC in order to find out the value of B. According to the law of sines in triangle EDC, DE over sinus 60 degrees equals to DC over sinus beta. Okay, according to the law of sines in triangle DEC, DE over sinus 60 degrees equals to DC over sinus beta. Okay, and we know that sinus 60 degrees equals to root 3 over 2, DC equals to 4 units, and we already found out the value of sinus beta. So the only missing variable here is DE, that is B. We have all the values of all the other variables. So we put the data inside this equality, and we found out that the value of B is actually root 7 times root 3 times 4 over 5 units. And we have already found out the value of A. The value of A is root 7 units. So we know the values of A and B, and the area of triangle, the green triangle FDE, equals to the base of the triangle that is B times the height to the base, that is A, over 2. Okay, so the area of the green triangle equals to A times B or B times A over 2. And we have already know the values of A and B, so the only thing that left is to substitute A by root 7 and B by the value that we have already found. So we substituted A by root 7 and B by root 7 times root 3 times 4 over 5, and we got the value of the the size of the area of the green triangle. The area of the green triangle equals to 14 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle equals to 4.85 square units. Again, the area of this green triangle equals to 4.85 square units. Okay, thank you very much.